Hello everyone. Today I am going to explain about assignment problem AP. We finished the transportation problem in the same manner. Assignment problem AP. Now what is assignment problem and how many methods are, how many types of AP assignment problems are there? How to solve the assignment problem, by using which method we have to solve the assignment problem, I will tell you today. Now assignment problem. Assignment problem is a special kind of transportation problem in which each source should have the capacity to fulfill the demand of any of the destination. Each source should have the capacity to fulfill the demand of any of the destination. If it is in this manner, then we say that it is assignment problem. Now in simple language, or in other words, I'll tell you, in our other words, any operator should be able to perform any operator, columns, operators means columns. Now jobs means rows. Any operator should be able to perform any job regardless of his skills, although the cost will be more if the job does not match with the worker's skill. If it is in this manner also, then we say that assigning jobs to the operators. Assignment problem. Assignment problem means assigning jobs to the operators regardless of his skill, although the cost will be more if the job does not match with the worker's skill. A sample assignment problem is in this manner. Operators, columns, jobs, 1, 2, 3, 4, 5 jobs, rows. Generalized format of assignment problem. Now the first row, job 1, 2, 3, 4, 5. That may be 5 rows or 6 rows or 4 rows or 7 rows, whatever, depends on the given sum. M number of jobs. In the same way, operators 1, 2, 3, 4, 5 up to M number of operators. That may be any number of rows or any number of columns. Now the sample generalized format of assignment problem is in this manner. Now this is the one generalized format. Now next, how many types of assignment problems? There are two types of assignment problems. There are two types of assignment problem. Number one is balanced assignment problem. The second one is unbalanced assignment problem. When will you say it is a balanced assignment problem? If the number of rows in the given AP, if the number of rows is equal to number of columns, then we say that it is a balanced AP. Otherwise, it is unbalanced AP. If the number of rows is equal to number of columns, then it is termed as a balanced AP assignment problem. Otherwise, it is unbalanced. If it is unbalanced assignment problem, first we have to convert that into the balanced AP and then we have to solve. How to convert it into the balanced assignment problem? You have to, depends on the problem, you have to if it is unbalanced assignment AP, then the necessary dummy row, or you have to introduce either dummy row or dummy column, you have to add in such a way that the given matrix, given AP will become a square matrix. If the number of, you have to add the necessary number of rows, or for example, in one problem only 4 rows, 6 columns are there. 4 rows and 6 columns are there. To convert, it is unbalanced AP. To convert such type of unbalanced AP, you have to add 2 dummy rows having all 0 entities, all entries, all zeros, 2 dummy rows, 0, 0, 0. Like that, if you add 2 dummy rows, then it will become a square matrix having 6 rows and 6 columns, like that. The problem is unbalanced AP. The necessary number of dummy rows or dummy columns are added such that the cost matrix will become a square matrix. The values of entries in the dummy rows and columns are to be 0. Like this, you have to convert the given AP into the, if it is unbalanced, you have to convert into the AP into the balanced AP. Now, how to solve how to solve the assignment problem. Now, to solve the assignment problem, we have only one method called Hungarian method. Hungarian. An assignment problem can be easily solved by applying Hungarian method. Only one method called Hungarian method. They'll give you one problem, solve the AP, or simply solve the AP by using Hungarian method. Sometimes they will specify the method name, or sometimes just solve the AP they will ask, because there is only one method, that Hungarian method only we have to apply to the problem. Now the typical assignment problem is given like this. Here first, by observing the problem itself, you have to identify whether how many rows and columns are there. In the first step itself, you have to identify. Now in the given problem, how many rows are there? In the given problem, there are 6 rows are there. Only 5 columns are there. The given AP, therefore writer will, the given AP is unbalanced. AP. If it is unbalanced AP, what we have to do? We have to convert this into the balanced AP by adding one column. I will add one column and a dummy column having zeros. Now by adding one dummy column, I converted the given problem into the balanced AP. I added one dummy column. Therefore, number of rows is equal to 6. Number of columns is equal to 6. This became a balanced assignment problem. Now, from here, the steps I will tell you the steps how to solve the problem using Hungarian method. Now, step 1. Step 1 is row reductions. Row reduction. I am reducing the rows. Now you observe the balanced AP. Whatever the balanced AP, if the given problem is balanced AP, directly you can start. In this problem, it is not balanced AP. That's why I am converting into the first I converted into the balanced AP. Now in the first row, the row minimum in the row. In the first row, out of the first row, complete row, the minimum value is 0. Second row, out of the complete second row, the minimum is 0. Third row, the minimum is 0. The fourth row, the minimum value is 0. Fifth row, the minimum value is 0. Sixth row, minimum value is 0. Now, whatever the row in the first row, whatever the value is there, minimum value you have to write. In the second row, third row, fourth row, like that all completely you have to write. After that, the minimum row value subtract from the first row. Subtract this minimum row value from the first row. 30 minus 0 is 30. 39 minus 0 is 39. 31 minus 0 is 31. Like that. The same values you will get. The same values I will write. Like this, we did the row reduction. The minimum value from the first row, second row, third row we wrote, and after that we subtracted that minimum value from the first row, second row, third row. Because all zeros are there, the same value we have got. The second step, step 2 is column reductions. Column reduction. In the column reduction, in the first column, out of the first column, which one is the minimum value? Complete first column. Observe the first column very much clearly. And the minimum value in the first column 30. The second column, observe it. And the minimum value from the second column 36, 31. In the same way, fourth column minimum value is 32. Fifth column minimum value is 34. Last column minimum value is 0. Now what we have to do? We have to subtract 30 from the first column. From the first column, whatever the minimum value is there, subtract from the first column. 36, subtract from second column. 31, subtract from third column. 32, subtract from fourth column. Like this, you have to subtract and write down the new matrix. In this manner, if you subtract the minimum value from the first column, from the second column, if you subtract such type of values, you will get. Now from here, what we have to do, I will tell you. You have to draw, after getting the row reductions, column reductions, first step and second step, we have to draw minimum number of lines to cover all zeros. We have to draw minimum number of lines to cover all zeros. You have to draw minimum number of lines. You have to draw this minimum number of lines in such a way that we have to cover all zeros. Now see, I will draw minimum number of lines to cover all zeros. I am drawing like this so that all zeros I cancelled. Now second one I cancel like this, and zeros are there here, 2 zeros. Now if you observe, I cancel the complete first column, I cancel the first row, after that 2 more zeros here, I cancel the fourth row also. Now all the zeros are covered or not? Any zero is open, open means outside like this. Now this zero, all zeros are covered with the line. Here also zeros covered with the line, covered with the line. Now these are any other zeros? Here one more zero is there. One more zero is there. That you can draw like this or like this, that is your wish. You can draw either vertically or horizontally. One more zero is there. Like this you check whether all zeros are covered or not. Now any zero is open outside. Any zero is outside. Now like this I covered all zeros. Now then this we cannot draw minimum number of lines. These are the 1, 2, 3, 4. The minimum number of lines to cover all zeros is equal to, we have got 4. Now to cover all zeros, then this we cannot draw much minimum number of lines. Now here depends on this step only, where did we reach optimal condition or not, we can find. Now if you get, now what is our purpose? We are drawing the minimum number of lines to cover all zeros in such a way that we have to draw the minimum number of lines in such a way that to cover all zeros. If the minimum number of lines to cover all zeros, 1, 2, 3, 4 we have got, is equal to number of rows and columns if you get, then the solution is optimal. If you get whatever the lines you have got, that number of lines, minimum number of lines to cover all zeros is equal to the number of rows and columns if you get, then the solution is optimal. The solution is optimal. There ends the matter. Our answer we will get. If not, see here how many lines we have got? We have got 1, 2, 3, 4 lines we have got, which is equal to number of rows and columns, which is not equal to number of rows and columns. Therefore, the solution is optimal. We have to move further. The code, we have to go to the second iteration. What to do in the second iteration, I will tell you. First, I will write. After drawing the lines like this, always draw the lines with pencil. The minimum number of lines to cover all zeros is not equal to the number of rows and columns. Hence, the solution is not optimal. And if it is not optimal, we have to go to the next iteration. What is the next iteration? How to go to the next iteration? I will tell you. Now, while going to the next iteration, now the minimum value from the uncovered elements. These are all covered elements with lines. Covered elements with lines. The minimum number of the minimum value from the uncovered cell. The minimum value from the uncovered cell. Identify the minimum value from the uncovered cell. What we have to do with that element? Now subtract that element from the uncovered cells and add the minimum number at the intersection point. First identify the minimum value from the uncovered cell. See, for example, if you see 1 is the minimum value. I identified 1. Now what we have to do with that one? Subtract 1 from the uncovered elements and add 1 at the intersection points. Intersection point means, now intersection point, this 0 is intersection point, this 0 is intersection point, this 0 is intersection point. 1, 2, 3 intersection points are there. You have to subtract from uncovered elements. You have to add at the intersection points. After drawing the minimum number of lines to cover all zeros, we have to write the minimum number of lines to cover all zeros is not equal to number of rows and columns. The solution is not optimal, and we have to go to the next iteration. Next iteration, how to go to the next iteration? Identify the minimum value from the uncovered entries. Here 1 is the minimum value. What we have to do with that one? Subtract 1 from the uncovered cells and add 1 at the intersection points. Now I wrote that one. The minimum among the uncovered cell is 1. Subtract 1 from the uncovered cell and add 1 at the intersection point, and then I have got like this. Now why? Because 13 minus 1 is 12. 1 minus 1 is 0. 1 minus 1 is 0. 2. Like this you will get. At the intersection points I added. Now what we have to do now? Again we have to draw the minimum number of lines to cover all zeros. Again the same procedure. Here 3 zeros are there, I covered. Here 1, 2 zeros are there, I covered. More 2 zeros are there, I covered. Now any zeros? Here 2 zeros are there, I covered. All zeros are covered. This one I covered. 1, 2, 3, 4. Here one more 0 is there. One more 0 is there, I covered. How many lines I draw? 1, 2, 3, 4, 5. Check whether all the zeros are covered or not. All the zeros are covered or not. Here all the zeros are covered. Now how many lines we have got? 1, 2, 3, 4, 5. Minimum number of lines to cover all zeros is not equal to, again also is not equal to number of, here number of rows and columns, how many are there? 6 columns are there. 6 columns and 6 rows are there. Number of rows and columns. The minimum number of lines to cover all zeros is equal to, here we have got 5, which is not equal to 6. Number of 5 is not equal to 6. Lines we have got 5. Here number of rows and columns is equal to 6 are there, which is not equal to, the solution is not optimal. The solution not optimal. Again we'll go to the next iteration. We go to the next iteration. How to go to the next iteration? Again from this. Now the minimum value from the uncovered entries. The minimum value from the uncovered entries is again here 1 is the minimum value. What we have to do with that one? Subtract 1 from the uncovered entries. Now add 1 at the intersection points. The minimum number of lines like this only we have to draw. There is no condition. That is your wish. You can draw either vertically or horizontally in such a way that the lines are minimum. The minimum lines only we have to draw, either vertical or horizontal. In this manner only, madam, draw like this. We have to draw in this manner. That is your wish. You can draw either vertically or horizontally. Now again the minimum value from the uncovered entry is 1, and subtract 1 from the uncovered entries and add 1 at the intersection points. We will get a new table. I will draw. Now uncovered, from the uncovered element 1 is the minimum value. What I did, I subtracted from the uncovered entries, and at the intersection points, wherever intersection is there, at that intersection points I added 1. I subtracted from the uncovered entries. The remaining entries I wrote as it is. Now again what we have to do, here we have to draw again minimum number of lines to cover all zeros. To cover all zeros, either vertically or horizontally. 2 zeros covered, here 2 zeros covered, and if you draw like this, 2 more zeros covered, 2 more zeros covered, this 0 covered, here 1 more 0 is there. If you draw like this, 1 more 0 covered. Now count the number of lines. 1, 2, 3, 4, 5, 6. Therefore to cover all zeros, I draw minimum number of lines. The minimum number of minimum number of lines to cover all zeros is equal to number of rows and columns. Therefore, the solution is optimal. Now, optimal solution we have got. Now, how to write the answer? I will tell you how to write the answer. Now, you have to put one box to the zero in whatever. Now, to find the optimal solution, we have to draw boxes to the zeros. We have to draw boxes to the zeros in such a way that the box should come in each row only one. Any column or any row, only one box should be there. In such a way, we have to draw boxes to the zeros. We have to draw boxes to the zeros in such a way that there should be only one box in any of the row or column. See here in the first row it is there like this. If I put one box here, again I should not put box here. I should not draw box here. In any row only one box or any column. Here if you see the third column, here box already we have got. That means we cannot draw any more box in the remaining. Here we draw one box means we cannot draw here. We cannot draw here. Now this is the only possibility. That's why this one. Here I draw box. That's why we cannot draw here. Here it is not useful. That's why we can draw here. Now the next one is we have to draw boxes in such a way that there should be only one box. Here already one box is there. That's why it is we cannot count this one only this one. 1, 2, 3, 4, 5, 6 assignments. Now 1, 2, 3, 4, 5, 6 rows. 1, 2, 3, 4, 5, 6. We have to draw one box in any row or any column in such a way that there should be only one box in any row or column. Now assignments are, this is row and column and time. Now first row assignment is in which column? First row in the third column. First row, third column. And second row, second column in the third one. Third row, fifth column. Third row, fifth column. Fourth row, 1, 2, 3, fourth column. Fourth row, fourth column. Fifth row, first column. Sixth row, sixth column. In this manner we have got. Now go to the given problem. In the given problem, what are the values are there? In the given problem, first row, third column. First row, third column, how much is there? 31. Second row, second column. Second row, second column, 37. Third row, fifth column. Third row, fifth column, 34. Fourth row, fourth column, 32. Fifth row, first one, 32. Sixth row, 0. If you add all these values, whatever the time you have got, that is the answer. How much if you add all? HRS. Total assignments is equal to 166 hours. Thank you very much.